Hi, I'm David with Portrait Displays, and in this video, we're going to calibrate the Panasonic TX65LZW2004. We're running firmware 3.111 using Calman Home for Panasonic, the G1 pattern source, and the C6HDR5000 colorimeter. Let's get started. I'm going to come over to the machine that I have Calman running on. I'm going to double click on Calman Home. With Calman launched, you'll notice we're here on the Calman introduction screen. If you're already familiar with Calman, you may not want to go through this, but if you haven't used Calman before, I highly recommend you go through the process of taking a look at what's around. For this video, we're going to come up to Calman, we're going to come down to Open Workflow Template, select Display Specific, and select Panasonic AutoCal. This is going to load the workflow specifically tailored for Panasonic displays. Now that we're on the Panasonic AutoCal workflow, we're going to want to select the display technology we're working with. We're working with an OLED today, so I'm going to choose OLED, and I'm going to start with the SDR mode for the display calibration. With those selected, let's press Next. On this page of the workflow, we're going to set up our session. To do so, we're going to want to do a couple of things. We're going to want to find the meter, find a pattern source, and set up our calibration targets for the SDR mode. So let's get started here with Find Meter. Now you may notice Calman connected to the Portrait Display's C6HDR5000 when it was started. But if you're not connected to your meter, I'm going to show you how to get connected. Let's come up to the Meters tab here in the top right. We're going to press Disconnect. Now over here on the left side, we'll choose Find Meter. Calman is going to search for the meters connected to the display and connect automatically. And there you have it. We've connected to the Portrait Display's C6HDR5000 in the top right. Our next step is going to be selecting a meter profile. You'll notice underneath the Find Meter button that there's another drop-down that has all the meter profiles included in the C6HDR5000. Because this TV is a WRGB OLED from the year 2022, I'm going to select OLED TV 2022, but we encourage you to select the correct profile for the display you're measuring. With the correct profile selected, we're now going to find our source. There are two ways with the Panasonic display that we can do this. One, we can use the internal pattern source built into the display and integrate into Calman, or the second method would be to use the G1 pattern source made by Portrait Displays that I happen to have connected to the HDMI input. I'd like to show you how to connect both, but we're going to do the calibration today using the G1 pattern source. So let's hit Find Source and start with the Panasonic's internal pattern generator. I'm going to select Manufacturer, Panasonic, and I'm going to select the LXLZ because of the model that I'm working on. Next, we're going to want to put in the IP address of the display so Calman can connect. To do so, press Menu on your remote, select the main menu by pressing OK, come down to Network, and you'll notice two options here. We have a network connection and a network status. If you haven't connected your display to the network, this is the time to do so. Connect it to the network connection and follow the instructions. I've already got mine on the network, so I'm going to come down to network status. Now when you press OK on network status, you're going to see that the Panasonic is going to do a validation. The TV is connected to the router, and the router is going to fully connect to the network. Once that happens, these items down below, such as status details, will become active. As you can see, we're connected to the internet, and I'm able to arrow over to status details and press OK. Here, I get all of the details about my network, and there is the IP address. I'm going to encourage you to write down the IP address instead of simply typing it in. We're going to need it later in this workflow. So I'm going to come over to Text Edit, and I'm going to type in this IP address, 192.168.9.182. I'm going to copy that, come back over to Calman, and I'm going to enter it into the IP address. Now you may think at this stage you want to press Connect, but the Panasonic doesn't let you simply connect because you have the IP address. Instead, you have to put it in a mode that allows a device to connect to it. So let's come back to our remote, press back again, and let's come up to Picture. In the Picture menu, we're going to arrow over and come down to the lock settings. Here we are in lock settings. We're going to press OK, and you're going to notice there's a pin. We're going to take the remote, we're going to press the I, and then we're going to type in 085. With the menu now unlocked, you'll see the ISF CCC network. We're going to arrow down to the ISF CCC network and press OK. The TV now has a waiting for connection dialog. We'll come back over to Calman and we'll press Connect. Calman has now connected to the display over the network. You can see in the top right here where it says Panasonic, and You'll also see underneath the find source, Panasonic. Now, because we're measuring an OLED, you'll notice on the right side of the screen, it does recommend a 10% window pattern. We're already in that 10% window pattern, but if you weren't, you can do so by selecting here. You can also use the open pattern source settings here to open up the dialog in the top right and further adjust your pattern source. Now, I mentioned that while we can use the built-in pattern source on the Panasonic like we're connected now, we can also use the G1 pattern source. I'm going to disconnect from the Panasonic, and I'm going to show you how to connect to the G1 pattern source, and we'll continue with that. I'm going to come up to the top right here where it says Panasonic, select it, and come down to disconnect. I've now disconnected from the Panasonic as a pattern source, and I'll switch over to the G1. Let's come back over here on the left and press Find Source. I'll now select from the manufacturer, Portrait Displays, select G1, and I'm going to type in the IP address of the G1. You'll notice it on the screensaver when it boots up, 10.23.10.215. We'll press connect, and we're now connected to the G1 pattern source. It's that simple. Now you'll notice the G1 also is at a window 10%, so we'll leave that at a window 10%, and we'll move on to the next step. Here, we're going to set our calibration targets. Right now, I'm in Rec 709 sRGB or BT 709, BT1886 gamma formula, and a white point of D65 at 317.329. We're going to leave that for the purpose of this demo, and we're going to press next. But if you do choose to change those, you can do so at that point. On this page of the workflow, we're going to take some pre-calibration measurements. We have our meter connected, we have our meter profile set up, we have our pattern source connected, our meters placed, and we're ready to take these pre-calibration measurements. So I'm going to come down to the bottom right and press Read Series. Calman's going to go through the process of putting up a pattern, taking a reading, and plotting the data so we know where we are when we get started here. Okay, with our pre-calibration measurements now completed, we can take a quick look at how the display is calibrated. If we look here on the RGB balance on the right, you'll notice we're coming out a little bit off that EOTF target that we're looking for. Ideally, we'd have this tracking that 100 line pretty well. Additionally, it does look like we're going a little towards red, and we've got some delta E errors that are ranging upwards of about 6.4 on the grayscale and 5.7 on the color here as you look at this color chart. So let's press next and let's see if we can get this a bit better. Next, we're going to want to connect to the TV. We've connected to our pattern source and we've connected to the meter, but we're not connected to the display where we're able to calibrate it. At this stage, we're going to want to find the Panasonic TV as a display and connect to it so Calman can control it. Let's press Find Panasonic TV. You'll notice that we're already set to Panasonic in the manufacturer of the Find Display window, and the model is set to the 2019 GZ. Let's select that and select our 2022 LZ model. Now we'll want to put in that IP address, and that's why I mentioned that you should write this down in a notes page so you don't have to keep finding it. I'll enter that 192.168.9.182. And lastly, we are going to want to put the TV back in the waiting for connection mode. So let's pick up our remote. We'll press menu, select main menu, picture, lock settings, and let's enter that code of I085. Select the ISF CCC network, press OK. It's waiting for connection. We will now press connect. And we are now connected to the Panasonic display. You can tell what you're connected to by looking in this top right corner. We've got the meter, we've got the source, and we've got the Panasonic now connected as a display. Now we want to select the mode we wish to calibrate. I have a couple options here. I have Pro 1, Pro 2, or the Dolby Vision modes. Since I'm calibrating SDR and not Dolby Vision, I'm actually going to select the Pro 2 mode for the purpose of this demo. I'm going to select the gamut BT1886, and I'm going to select the color gamut at BT709. And now I'm going to reset the selected mode. What Calman's going to do is set a baseline of the settings so it has a good starting point for the process of calibrating. Let's press next in the bottom right. On this page, we're going to set the luminance. Now, I'm going to target 100 nits or 100 candelas per meter squared. I'm doing this because in a reference environment, a content creator is going to target about 100 nits. But I am in a very bright studio. I've got a couple lights around me. I've got some light shining on the display. If I was going to watch the display in this kind of environment, I might want to target maybe 150, maybe even 200 nits to have that brighter image for a brighter room. I recommend that you set this to a luminance level that you see fit for your environment. So let's press measure luminance. And Calman's going to put up a pattern and take a reading, and then report that reading under this peak luminance setting here just below. We're currently at 99.2. So I'm going to come up to this display controls, hover over it, and press the plus sign. That now brings me up to 102.4. I'd rather target a little bit higher because as I calibrate the display, I might lose some light than starting too low. So with this at 102, I'm going to press stop. I'm going to come down to the bottom right and press next. The next part of the workflow is to do the 2-point grayscale. This is going to put up a white patch and a dark gray patch and optimize the grayscale from a coarse level. Let's press the auto cal button down in the bottom right corner. And now we have some active grayscale points. Currently the 2 points set to 30 and 100%. You can change these, but Calman has been optimized for what we think is the best overall setting for calibrating these displays. I'm going to leave it there. I'm going to leave my delta E target at 0.5. I'm going to press OK. During this process, Calman's going to put up a patch, take a reading, and make adjustments to get it as close to the target as possible. Okay, that completed successfully. It took 24 seconds and a total of 14 reads. Let's press OK, and let's press next. On this page of the workflow, we're at the gamma setting. You'll notice it says confirm the gamma setting for the display. This part is very interesting. We're not actually going to calibrate the gamma point by point at this stage. We're actually going to choose the best gamma setting to start with in order to achieve our goal. So what Calman wants you to do now is come down to the bottom right and press Read Series. On the left side, it's telling you the target, which is ITU B1018A6, and it's telling you that the gamma control in the display is actually set to B1018A6. So think of it this way. The display has a user menu, which you can go into when we're not connected with Calman, that has different gamma tables. It might range from, let's say, 1.8 to 2.6. You can choose one of those tables and make a correction. Let's look at that a little bit further. If we take a look at the chart here of what we just measured, you'll notice the near black is pretty good. You'll notice that the near white is okay, and it starts to come out in the mid-range here, and right around this 15 to 20%, we have this big hump. Well, let's take a look at why we don't want that hump. I'm going to pull over a whiteboard here, and let's take a marker. You'll have to bear with my chicken scratch. So let's take an X and Y chart, and we're going to plot that yellow target line. So let's say this is our yellow target line. Now we just measured a gamma that kind of goes like this, right? And bear with me here. So we have our target line and we have where we measured. We want this, but we're currently measuring this. Now on the Panasonic display, we actually use a multi-point system that has a range of adjustments. We might be able to go from, say, -50 to +50. So let's say -50 here, and we have +50 here. So what we need to be able to do is we need to be able to move from this point to this point without running out of the range. If we run out of the range, we're not going to be able to bring this all the way into the target. So what we want to do at this stage of the game is we want to get this gamma curve as close to the target as possible so that we use less points during the correction process. This actually optimizes the image processing in the display and makes it so that you get consistent results every time. So let's come back to Calman and we'll take a look at how we're measuring. So I'm back at Calman, and I didn't really like this hump that we have right here. So I'm going to come over to my gamma control, and I'm going to start wide. I'm going to come down to 2.6. So I'm going to set the table inside the display to 2.6. Now that should bring us down because 2.6 is much darker coming out of black or slower coming out of black than B1018A6. So that should bring this gray line closer to that yellow line. I'm going to open up another history so we can take a look at this, and I'm going to take another sweep. We'll be able to see the difference that occurred from the B1018A6 to the 2.6, and what we want to see is that closer to the target line? Okay, so as you can see, we're tracking still pretty well with this yellow line until we get to that 1520. We still have a hump, but that hump is a lot less than it was when we were measuring before. Then we come in and the top hasn't been affected too much. So let's come back here, and we're currently on history 2, but let's look at that history 1 to see where it was. Oh, look at that. You can see how much wider that gap is between the target and what we measured at 2.6. So I feel pretty confident that where we are right now is probably where we're going to want to be. We have plenty of adjustment for Calman to correct the EOTF even further. So let's press next. And now we're at the grayscale multi-point portion of the workflow. This is where Calman's going to go through that fine tune. It's going to do the white balance. It's going to do that gamma correction. So let's come down and press the auto cal button. So we come over to the active grayscale points. You'll notice there's a number of points, but only 2 of them are for SDR, which is what we're calibrating right now. So I have a 12 point and a 14 point. And what I've done as best practice in my own calibrations is I'll close this window come up to the DDC controls here in the top right, and then look at the amount of points Calman has for the adjustment. If I select 14 points, but it only has 12 points, I might not have the best calibration because I'm actually trying to calibrate points I might not be able to. So I see here that I have 12 points, so now I'll come back down to that auto cal. I'll select the 12-point STRLZ 2000, leave the delta E target at 0.5, and press OK. Calman will now go through the process of optimizing that grayscale and EOTF. Okay, our full grayscale calibration is completed successfully. The time took 12 minutes and 6 seconds, and we took a total of 151 reads. Let's take a look at the results. As you can see, our RGB balance without luminance is tracking really well with red, green, and blue pretty much on top of each other at our target. If we look at it with luminance, we will see a little bit of a hump here. My assumption is that we probably still didn't have enough range within the control to get it just right. We can check that by coming up here to that DDC control. Let's come up to the top right and let's take a look. So if we take a look at the numbers on the side and we go from near black at 2 all the way up to 100, we can see that red, green are at -50, and the luminance, the value that controls the EOTF curve, is also all the way at 50. So Calman's pushing all the way down to try and get this right. It's basically run out of range. We can see as we get into that middle range, 9.6, 19.6, 29.7, you'll also see this luminance all the way down at -50 over here, and we still are taking down the red, green, and blue in order to get it a little closer. So what that tells me is, even at 2.6, we've run out a little bit of the range to get that right. But if we come down to our delta E2000 chart here, we'll notice that these errors are still pretty low. If we come over to our EOTF chart on the left, we can see we're tracking that much, much better. We can see right here where we have that yellow and that gray separation. Same thing down here, we get a little bit of that. So let's press next and move forward with the calibration process. And now we'll optimize the color gamut mapping. The Panasonic uses what's called a CMS system, a color management system. And what it does is it has multiple points that you adjust that then scale to the points around it. So as you can see on the CIE chart here on the left, we have red, green, blue, and magenta. I'm going to press the Auto Cal button, and that'll bring up the Auto Cal setup dialog. We have a couple options here. We have saturation set, saturation point, stimulus level, and our delta E target. Calman once again has been optimized for the values our engineers have found work best with this display. Of course, if you want to experiment, you can change these. What ends up happening is you want to adjust the point closest to where the display is set its scaling point. So if it's optimized at 75% and then it calculates the values around that based on where that is, you want to make sure you're optimizing that target. If it was optimized for 100%, we'd set it to 100%. Let's press OK and let Calman go through the AutoCal process. All right, the full gamut calibration is completed successfully. It took 1 minute and 43 seconds, and we've taken a total of 65 reads. If we take a quick look at this, you'll notice that the measurements are inside the target boxes. So it looks like this came out pretty well, but let's press next in the bottom right-hand corner. And now on this page, even though it says dynamic range, really what we want to use this page for is we want to use it to recheck that luminance value. So for example, we set it to about 102 nits when we started the process. We've now gone through the calibration process of optimizing that EOTF, optimizing the white point, and setting the color gamut mapping. So we might have lost a little bit of luminance or perhaps gained it. So let's select 100 down here in the bottom left for 100% white, and I'm going to press read on the bottom right here. So take a reading. It's going to plot this here under peak luminance. And we're at 107.1 nits. So I'm going to come up here to luminance, and I'm going to take that down 2 clicks. And we're at 101.2. So let's go down one more to see if we can make this work. And we're at 96.6. So I'm going to come back up to 29, hit read single, and we're at 101.4. So at this point, I'm going to leave it at 29 because I'd rather be a nit higher than a couple nits low. And I'm going to press next. Now we're at the post-calibration validation part of the report. So I'm going to hit read series and let it do its measurements similar to the pre-calibration. Okay, our post-calibration verification is completed, and at a quick glance, things are looking pretty good. If we come up here to the display performance, we can see the color performance has an average error of a 0.6 delta E with a max error of 2.2. The grayscale performance has a max error of 0.7 with an average of 0.3. So we're doing really well on that grayscale, even with this hump. And where we do have a little bit of error on the color seems to be in that cyan channel. Blue sky at a 2.2. Not bad considering we only had a few points to measure. Let's press next and see how that compared to our pre-calibration. If we look at the pre-calibration chart on the top against the post-calibration chart here on the bottom, you can see our max delta E was 6.4 when we started, and we're now at a max of 0.7. We have an average delta E of 4.7 in the start, and an average of 0.3 after the calibration. If we come over here to the color checker, we have a max of 5.7 versus a max of 2.2, and an average of 4 versus an average of 0.6. So we have significantly improved the calibration of the Panasonic by going through the process. But there's still a couple things to do. We've only calibrated the SDR mode on the Panasonic at this point. But what if we're watching HDR content? Let's go through the process to calibrate HDR. We're going to come back down to the right, we're going to press Calibrate HDR, and we're going to start the workflow process over. I'm going to go a little bit faster through the process since we've already been through a lot of this in detail, but it's still important to go through the different steps that might apply to HDR versus SDR. Let's come back up to the top left. We're not going to change our meter. We have our source, and we have our window at 10%. We're going to keep our window at 10%, but what we're going to want to do now is we're going to open our pattern source settings, and we're going to want to set the generator to HDR. If we look on the right side here, you can see HDR is currently off. Let's click on that and change it to HDR. This is going to send an HDR signal to the display. You're going to see it go into the HDR mode. We have HDR PQ, and now we can close this panel by clicking off it. And we'll move on to step 3. You'll notice our targets are already changed to Rec 2020, ST2084 at D65. Calman intelligently knows that you selected HDR calibration, and it set the most common HDR targets automatically. We're going to leave it there for now, and we're going to press Next in the bottom right. Once again, we're taken to our pre-calibration measurements, but now we're doing a pre-calibration for HDR. Let's press Read Series. Okay, you can see our pre-calibration readings have finished. You can see we're going a little bit red. We're not too bad on tracking the PQ curve. We do have this little bit of tone mapping happening here, although I do expect some tone mapping happening here. We'll talk a little bit more about that later. We also have the color gamut mapping not quite hitting where we want it to hit. We have some delta E's hitting as much as about 5.5 here. Let's press Next and let's move forward. So we're already connected to the TV, so we don't need to connect again. I'm going to stay in the Pro 2 mode. I can of course select a different mode, but I'm going to stay in the Pro 2 mode for now. And I'm going to turn on HDR because we're calibrating HDR. I'm going to select the BT 2020 color gamut. I'm going to hit Reset Selected Mode to reset the display for the start of the calibration. You'll notice the gamma has been changed to 2.2. HDR is on, and we're in BT 2020. So let's press Next. And now we're at a unique point in the calibration of the Panasonic. Because we're calibrating in PQ and not a power function EOTF, we want to set the HDR roll-offs of the tone curve. For the LZ2000A, it's recommended at 1000 nits. Now I'm on the LZ2004. However, we don't have a specific setting for that, so I'm going to choose the one that's closest to my display. I urge you to do the same. This says we should set the max mastering display luminance and max CLL to 1000. We'll come over here to our pattern source and we can look at the max mastering display luminance and the max CLL, and they're already set to 1000. So I'm going to leave them right there. I'm going to press out of the menu. I'm going to come down here on the right and press Next. Once again, we're at that grayscale 2 point. So let's hit that auto cal in the bottom right, bring up the auto cal menu. We're going to leave the active grayscale points where they are, and we'll press OK. Okay, our grayscale 2 point is completed. Let's press Next. And now we're on the grayscale multi-point portion of the workflow. Now remember, in SDR, we found we had to shift that gamma in order to get closer to our EOTF target. So instead of starting this with the auto cal button right away, I'm actually going to come down here to the right. I'm going to hit Read Series. I want to see how well we're tracking PQ in case I have to start from a different EOTF setting or gamma setting in order to get as close to the target as possible. Let's take a look and see where we're at. Okay, so I've taken a measurement of our EOTF here, and as you can see, once again, I have a little bit of separation here. And I don't really want that separation because I think I'm going to run out of range in trying to correct for it. So I'm going to come over here to the DDC controls. I'm going to hit the right arrow again, and I'm going to come over to the display controls as you can see on the top, and now I can make some manual adjustments. So the gamma currently is at 2.2. We're in the 2.2 memory that we're going to start the calibration process from. So if we look here, we have from 1.8 to 2.6. I actually think I might not have to go all the way to 2.6 because I don't want to mess up that top portion of the curve there. So I'm going to go to 2.5. And now I'm going to, once again, make another history, press the plus sign, and hit Read Series. Let's see where this gets us. Okay, so our measurement has finished, and if we look here in the top right, the EOTF is tracking a bit closer throughout. We have come a little bit lower on that top end, but we're also closer on that bottom end. Let's toggle back to History 1 and compare. You can really see it down here on the bottom end. We're significantly closer to our target. But we've also, again, set that top part out. So what I'd like to do now is I'd probably like to work with this and see if Calman has enough range to get it right where we want to go. Let's delete this history. Let's go back to History 1. And there's one thing I want to talk about, and we'll talk about this while the AutoCal is running. You'll notice as we come up this PQ curve, we have this gray line kind of jump all the way to the end. You can see it here on the top, it's slightly less. You can see it here on the top right on this luminance chart. And you can also see a little bit of that right here in the middle. I'm going to talk about that in a minute while this runs, but let's come down to the bottom and press AutoCal. We'll come over to Active Grayscale Points, make sure you've selected the HDR points for your display, and press OK. Now Calman's going to go through that Grayscale AutoCal adjustment, and let's take a look at the whiteboard here. Let's talk about that tone curve. So there's a couple ways to chart PQ. Calman has some unique ways of doing it itself, but if we look at the chart and what it looks like in Calman, we have X and Y, and we're coming up, and then we come over. This is the hard clip. So in a theoretically perfect world, PQ is going to come up based on our mapping. We're going to come up, we're not going to stop, we're going to hit 10,000 nits. But today, displays don't hit 10,000 nits. In fact, I don't think at the shooting of this video, any consumer TV sold today hits 10,000 nits, and certainly not at the 10% window we're measuring here on the Panasonic display. So what does that mean? Well, content, luckily, doesn't really get mastered at 10,000 nits. There's been some demo content and some experiments, of course, at 10,000 nits, but for the most part, content's mastered on mastering displays around 1,000 to 4,000 nits. There's a few outliers there, a little bit higher, a little bit lower, but most displays today are between that 1,000 and 4,000 nit range. Now, what happens if you have a display that, let's say, does 1,000 nits, but this is 4,000 nits. So if we're here on the chart and this line represents about 4,000 nits, but your display only does 1,000 nits, and that content goes up, we can't map it all. So we have a couple options here. We can come up and we can just hard clip. We come up and let's say we're at 1,000 here, so we hard clip and we're at 1,000. Well, at that hard clip, we now lose all of this data that's up here between these 2 points. It's just clipped out. So let's say we're looking at a bright headlight or the sun or some clouds that are really, really shiny. Anything in those specular highlights, something really, really bright. It's just going to look like a white blob. It's going to be clipped out. We're not going to see it. We're not going to know it's really there. We're not going to see that rich detail that we want in our content. So what we end up doing in video displays in our video system is we roll it off. So we come up and we're tracking that PQ curve, and then instead of hitting 4,000, we'll start to roll off. And what we're doing here is we're rolling off some of this data. So instead of having what's at 1,000, we're bringing that down a little bit. So maybe 1,000 here, and 2,000 here, and 3,000 here, until we get to that 4,000. And that way, we don't hard clip anything. We still see that rich detail. It's just muted down a little bit. It's not quite as bright as we want it to be, but it's still there. And by tracking the curve as close as possible near the bottom end where most of our content lives. Actually, there's been some studies. Most content is under 200 nits. Let's say this is 200 nits. Most content's under 200 nits. In fact, even more content's under that 100 nits. When you start getting above 200 and 300 nits, we're actually talking about a very small percentage of our content. As we start getting above 500 nits, we're talking about probably less than 1% of the pixels in these movies today are actually above that 500 nit. So most of your content's going to look really great if you're down here below that, and then that little bit that's up there, it's just going to look a little bit muted. So what you're seeing on the chart here when we look is we're seeing a little bit of that tone mapping, a little bit of that roll off as we make that measurement, and that's to be expected, and you might see that on many displays. Some displays have a hard clip where you can set it to a hard clip and you can get rid of that. Other displays do not. It really comes down to what you're working on. So our process is still going here, and we're going to let it finish. Okay, our full grayscale calibration completed successfully. It took 23 minutes and 22 seconds and 232 reads. Let's press OK and let's take a look. As you can see, On the top left here, we are tracking this EOTF pretty nicely all the way up until about that clipping point at the top, or I should say the roll-off point at the top. We also have this down here now tracking very, very good until we get up to that roll-off point. And as we look at the RGB balance with luminance, we see this is tracking really, really nicely. We get to that roll-off point. We do have a little separation there, but if we look at our delta E's, we're still pretty low. Same thing here on the RGB balance. We do have a little bit less green at the very top there. Let's press next and go to the next page. And now we're at that color space calibration again. Let's press the auto cal button in the bottom right. This is now set to 50% saturation set, 50% saturation point, a stimulus level at 50, and the delta E target point at 5. Once again, these are the ideal values our engineers have come up with as a starting point. Let's press OK and start the auto cal process. Okay, our full gamut calibration completed successfully. It took 4 minutes and 30 seconds and 141 reads. Let's press OK, and we can see that our measurement dots are in the target boxes pretty much all around as best as they can be. We are losing a little bit here on green, but let's hit the next button and see how the color gamut is mapping on the post-calibration report here. So we're going to hit Read Series. We're going to do the grayscale EOTF calibration like we did for the pre-calibration, and we're also going to do a color checker here as you see on the CIE, so we'll get a better idea of how everything came in. Okay, our post-calibration verification is finished. Let's take a quick look. It looks like our color performance has an average error of 0.7 with a max error of 2. Our grayscale performance has an average error of 0.7 with a max error of 1.4. Our RGB balance here is tracking very nicely across until we get to that tone mapping section, and then we just have a little bit of color fringing here. But if we look at the delta E 2000 values, once again, our max error is 1.4 with an average error of 0.7. Our color checker values have also come down, and we are tracking pretty nicely within this BT 2020 PQ space. Let's press next and take a look at our pre versus our post calibration. If we look here on the top left, this was our pre-calibration measurement. We have a larger roll off here, and then we have a little bit going towards red. Our max delta E was 5.5. We took that down to 1.4, and we had an average delta E of 2.7, now down to 0.7. Our max delta E 2000 on the color checker was 8.9. We're now down to a 2. And our average at 4.5, now down to a 0.7. So we made significant improvements here on the HDR memory of the Panasonic display. However, we still have one more mode we want to do. We have the Dolby Vision mode. So I'm going to come down here to Calibrate DV, or Dolby Vision. We're now going to come back to that start of the workflow. Calman's going to adjust itself. You'll notice the color space is now DCI-P3, SG24, D65. But let's walk through the workflow and get everything optimized for the Dolby Vision calibration process. There's nothing to do with the meter. We have nothing to do with find source, except you'll notice over here in section C, set pattern generator output to Dolby Vision with absolute metadata for validation and relative for calibration. So we're going to open up these pattern source settings, and we're going to change the HDR setting here from HDR10 to Dolby Vision. And since we're going to start with a pre-calibration, I'm going to change this from perceptual to absolute. We're in absolute. I'm going to click off the menu. We're going to check our targets. We don't want to change these. We're in color space DCI-P3, gamma formula SG24, and white point D65. Let's press next and move on to the next step. Now this Dolby Vision signal check step is really about making sure that the metadata from Dolby Vision has reached the display properly. We've switched over from HDR, and some metadata is sent to the display when we do that. Sometimes, depending on the signal, depending on the handshake, that doesn't always work exactly as we hope, although most of the times it does. This step is to make sure that we've got it right. So what we're looking for here is the black background with the white patch versus what you see in the workflow where it's a red background with a yellow patch. Since we have this in the correct state, we're going to press next. Once again, we're at our pre-calibration measurement page. Let's press Read Series and see how it's performing. Okay, our pre-calibration is finished, and as you can see, we have a lift in the EOTF here, and we come back down. Our delta E targets are actually not too bad. We have an average error of 2.1 with a max error of 3.9, and our color has an average error of 3.3 with a max error of 3.8. Let's press next and move on through the calibration. At this stage, we don't need to connect to the Panasonic TV because we're already connected to the Panasonic TV. We're going to select the Dolby Vision Dark mode if you're not already in it. We can start with that 2.2 EOTF, although we may want to look at it based on those pre-calibration readings. keep it in HDR, and hit Reset Selected Modes. Now that you're resetting the selected modes, you're going to notice that the pop-up comes up on the right with the pattern source because we want to change that Dolby Vision mode from absolute to relative. Once you're in relative, press Next. Now we're at the 2-point grayscale optimization. Let's press Auto Cal. We're going to use the 2 points at 30 and 100% as the default and press OK. Okay, our Auto Cal is completed successfully. 25 seconds, 17 reads. Let's hit OK and come down and press Next. Okay, we're once again to the grayscale multi-point portion of the workflow. I'd like to hit Read Series, as we've done before, to see how that EOTF tracking is and see if I need to move off that 2.2 EOTF that was default when we set up the calibration session. Okay, so our measurement's completed, and as we can see, we're coming out of black a little bit slow, but then we come out a little bit high here, even at that 2.2. I'm going to come over to the DDC control. I'm going to change 2.2 to maybe closer to, let's say, 2.4. And now let's come over here and press plus, go to History 2, and hit Read Series. We're going to see if that improves it and gets it a little bit closer so we can get better results with the Auto Cal. Okay, our reading is finished. If we look at this EOTF chart, we're actually tracking a little bit lower here, but we've got this middle point a little bit closer. So I think overall, we're probably a little bit closer throughout the range. I certainly don't want to go any further because we're starting to see some error near white, and we are starting to see that bottom end come a little bit too low. So let's keep it here, 2.4, and let's see how this comes out. I'm going to delete the History 2 by right-clicking on it and selecting Delete. And now in History 1, I'm going to press the Auto Cal. I'm going to select 12-point Dolby Vision, LZ2000, and we're going to press OK. All right, so our calibration is finished, and as you can see, we've got a pretty good grayscale going throughout. We do have a little bit of error as we come down here. We've got a pretty decent EOTF. We do have a little bit of jaggedness. A little bit here. We have a high of about 1.9 delta E, and we're tracking that EOTF fairly nicely. Let's press Next, and let's create the Dolby Vision configuration file. So I'm going to press Create Dolby Vision Configuration. This is what's going to help with the gamut mapping on the display. Calman's going to put up some patterns, take some readings, load the configuration in, and then we're going to switch our pattern generator back, and we're going to do some post-cal. Okay, the Dolby Vision file has been completed. We'll press our source settings, change our Dolby Vision mode from relative to absolute, and let's press Next. We're now on our post-calibration verification page. We'll press Read Series, and let's see how it came out. Okay, our post-calibration is completed. As you can see, our grayscale is tracking fairly nicely. Our delta E's are quite low. We do have a little bit of spike here at this gray 50 setting, but our color gamut is coming in really nicely. Our average error is a 1.3 with a max of 4.6 on the color, and an average error of 1 with a max of 1.8 on the grayscale EOTF. Let's press Next and compare our pre and post calibrations. So pre-calibration, we had a max of 3.9 on the grayscale. Post, we have a max of 1.8. On the grayscale pre-calibration, we had an average of 2.1, and now we have an average of 1. So we've made some improvement here with the calibration overall. As we come over to the color checker, our max error when we started was a 3.8, and we're now up to a max 4.6. Now, I don't like to see that. We do have a little error there. We might be able to go into the DDC controls and tweak this a little bit. But as you can look at the chart, you'll notice that the colors are a little bit high overall, and that average error is a 3.3, whereas our new average error is a 1.3 with one outlier that's kind of spiking there. If we look at the others around it, our next one's about a 2.5. So if we got rid of that one outlier, we are going at 2.4. Still not the most ideal, but certainly an improvement. If you look at the CIE chart, you'll see the dots are now in the target boxes much more throughout than they were pre-calibration. So there you have it. We've calibrated the Panasonic OLED for SDR, HDR, and Dolby Vision. I hope you enjoyed the video. We'll see you on the next one.